Today we're going to go through a Leetcode coding challenge. We'll go to the Leetcode website and I'm going to choose an appropriate Leetcode coding challenge. Then I'm going to code it in C, and then you can see the breakdown of how I think, what I'm thinking through as I'm coding this challenge. For those of you who don't know what Leetcode is just an online platform that gives you some coding challenges that you can do between half an hour to an hour. And they're really good because they give you some training in terms of implementing algorithms, solving some common coding problems, and also it helps you as you prepare for your coding interviews. When you go to these coding interviews, they may give you some coding challenges, and if you've done some Leetcode coding challenges for practice, you'll be well prepared for that interview. In this coding challenge, I'll be giving a bonus, and that bonus is I'll be going over a simple sorting algorithm that's really easy to understand, and it's the first algorithm that I learned in university. It's called bubble sort. And if you don't know what it is, stay tuned because I'll be going over it in this video. I'm Henrik, and I'm here to help you learn the software skills and tools you need to grow in your software development journey. So let's get started. By the way, if you're in the early stages of your programming journey, I've got a special gift for you. It's called my 30-day beginner coding challenge. And it's a guide that will take you from no coding experience to building your first 4 projects. And the best part is it's free. It's a free gift to you. In this coding challenge, I guide you in 30 days to build 4 programming projects, and I give you some tutorials that are in C. But of course, these projects are really generic and really beginner friendly, and so you can actually code them in different programming languages. You can still benefit from this guide because you can just take the principles that are in my challenge and then apply them to your programming language. You can find the challenge in the link in the description, and if you download it and pay attention to what it says, you'll definitely learn some fundamental programming concepts that will give you a good foundation to your software development journey. Alright, this is the main page for Leetcode, and if you just scroll down, let's go to the questions. So we'll look at the questions that they have, and they have different study plans, and we're going to go to the top interview 150, and let's just start with the first one. So merge sorted array. So let's go to this one, and then it'll bring you to this dashboard. So you have the description of the problem here, and then you have the place where you can write your code here, and then you can run it, and you can also submit it. And then they have the test cases here. It'll tell you if you pass the test cases or not. So the problem is you're given 2 integer arrays, nums1 and nums2. They are sorted in non-decreasing order. And then you have 2 integers, m and n, and then they represent the number of elements in nums1 and nums2 respectively. And the goal is, the task is, you want to merge nums1 and nums2 into a single array sorted in non-decreasing order. And there's an important note here. It says the final sorted array should not be returned by the function, but instead be stored inside the array nums1. So after you merge the arrays and sort them in non-decreasing order, they should just be stored in nums1. So to accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of 2. And here's an example. So they have 3 examples here. I think the first one is more interesting. Oh, they have the explanation here. So basically the arrays that we are merging here are 1, 2, 3 and 2, 5, 6. So the result should look like this: 1, 2, 2, 3, 5, 6. So they're merged. So that's this array and this array combined, and then it's sorted in non-decreasing order. All right, so let's get started. So first, we're not going to do it in C++ or Java or Python or whatever. We're going to do it in C because C is better. All right, so here's the function merge. It has 6 arguments. It has nums1, num1 size, and m that corresponds to the first array, and then nums2 size, and n, which corresponds to the second array. So what I'm thinking about doing first is, since we know that we should store them inside nums1, my first thought is let's put all of nums2's contents into nums1. So let's go to the example. It's always helpful to have something concrete to be thinking about. When you do these coding challenges, try to look at the example. Don't try to solve it with a generic solution. Try to solve it for this specific problem and then generalize it after. So the 2 arrays we have are 1, 2, 3 and 2, 5, 6, and nums1 has enough space for both arrays. So my first thought is, why don't we just put 2, 5 and 6 into this part of the array. So my thought process is, I want to do a for loop, and we'll do a for loop using int I. All right, so that's the basic structure for a for loop. Now I don't want to start at 0. I want to start at this index. And how do I get to that index? It's just going to be, I don't start at 0. This is 0. So I want to start at 0, 1, 2, 3. I want to start at 3. And m is equal to 3. So what I'm going to do is I'm going to start at m. And then we're going to go up to nums 1 size. And then we're just going to do I++. So we're going to store nums 2 inside nums 1. So nums 1 I is equal to nums 2 and some index j. And j, we should initialize j to 0 because we're going to start from 2. So we're going to 2, 5, 6. So we're going to start at 0 and then we're going to increment j. So after this is done, I should have an array that says 1, 2, 3, 2, 5, 6. So let's run that. Oh, you need to sign up in order to run the code. So I actually do have an account. So let me sign in real quick. Okay, let's run that. Okay, so wrong answer, and I kind of knew that, but hey, I passed cases 2 and 3. That's pretty good, but let's look at case 1. So of course, we didn't pass this one because all I did was I just combined those two arrays. I just put 2, 5, 6 at the end of 1, 2, 3, and that's what we got. So 1, 2, 3, 2, 5, 6. So that's good. So this part of the code works. So this section is just to merge nums 2 to nums 1. Alright, now this is the sorting algorithm that I was talking about. So we're going to do bubble sort. So if we look at the output here that we got and we want to get to the expected, all we need to do is swap this element with this element. And that's because 3 is greater than 2. So right away you should be thinking for sorting is we want to go through all of the elements and we want to be able to swap these two elements. Right away I can think of, we do another for loop. So we'll use the same format as this one, except we'll start from 0, go all the way to nums 1 size. And so after that, we want to do a check. So we want to check if nums 1 I is greater than nums 1 I plus 1. So if this element is bigger than this element, we want to swap them, right? So we're just going to do a check, and if this element is greater than this one, then we swap them. So in order to swap them, we need to have a placeholder variable. So what we're going to do is we're going to store this 2 over here, and so we're going to overwrite this one, but we don't want to lose this information. We don't want to lose that 3 when we put the 2 in there. So we want to store the 3 in some sort of placeholder. So nums 1 I is going to be stored in placeholder. Placeholder will hold that 3, and then meanwhile we can take 2 and put it in 3. So we're going to take nums 1 I, and then we're going to set that equal to nums 1 I plus 1. So if this number is greater than this one, we put this number in a placeholder, and we put the smaller number inside this index, and then we take the I plus 1 and we put in the larger number, which was placeholder, which was stored in placeholder. In this example, say I is equal to 0, 1, 2. Say I is equal to 2 in this iteration. If it's 2, then 3 will be greater than 2. So then the 3 will be stored in placeholder, and then the 2, which is this one, will be stored in where 3 was, and then 3 will be stored in where 2 was. So basically it's just a swap. So this is where the swap happens. And then, so we need to declare this variable first. So let's go to the top. All right, so we declared the placeholder. Let's run that again, see what happens. Okay, now we're having a runtime error. And the runtime error is happening because, okay, I think we're having a runtime error because we're accessing a location that is not allocated. All right, so nums 1 size is 6. So we'll go in here if I is equal to 5. And when I is equal to 5, this one will be okay, but if you do 5 plus 1, it's going to be 6. And you're going to be accessing the 7th array, or the 7th element of the array. So we can't go all the way up to nums 1 size. We need to go to nums 1 size minus 1. All right, so there you go. So now we actually, our case 1 was actually passed. We actually got case 1. So if you look at our output, it's matching the expected. So this sort is good enough for this test case. And that's because this test case was really simple. We only had the 3 and the 2 here. So basically we just went through the array one time, or we went through the elements one time. So we compared 1 and 2. If 1 and 2 is correct, then we didn't do anything. And we went to 2 and 2. That was correct, we didn't do anything. And then we did 3 and 2, and then we did the swap there. And then we did 3 and 5 and everything was okay, and then 5 and 6 and everything was okay. So that's why we were able to get it with just one for loop. So say this was the merged array. Now if we do this for loop, we're gonna compare these two, then we're gonna swap those two because 6 is greater than 5, and then we're gonna compare these two, and then we'll do the swap there, and then we're gonna compare these two, and then we'll do the swap there. Then we're going to compare these two, and then we'll do the swap there. And then we're going to compare these two, and then we'll do the swap there. So we did the for loop, we did 5 comparisons, and that makes sense because this for loop, it only goes 5 times. It starts at 0, and then we did 6 minus 1, so 5. So we only went through this swap, we only compared 5 times. We did this if check 5 times, and then we did the swap 5 times. So it took 5 comparisons to bring 6 to the right spot. And you see, if we only do the for loop one time, the array is not sorted yet, but it's partially sorted. The largest element is able to be brought to the last element. So now let's use the same idea. Let's do this swapping thing again. So we'll go through the for loop again. So we're going to compare 5 and 3, and then we're going to go through again. We're going to compare 2 and 5, and then they're going to do the swap there. And then we're going to compare 2 and 5 again, and then we're going to do the swap there. Then we're going to compare 1 and 5, and then we're going to do the swap there. Now if you notice there's something different, we don't have to compare these two because we know 6 is the greatest element of the array, and 6 will be brought to the last spot, so we don't need to do this one. So we actually only need to do 4 comparisons to bring 5 to the right spot. Now let's do the same for loop again. So we'll compare 3 and 2, and then we'll do the swap here. So that's 1 comparison, and then we're going to do the swap here, and then we'll do the swap here. So you notice that time we only needed 3 comparisons, and then you can guess we will do the comparison here, and they're the same, so no change there. Then we'll do the comparison here, and then 1 will be brought here, and then 2 will be brought here because 2 is greater than 1. So we only needed 2 comparisons. And then lastly, we only need to compare these two to bring 2 and 1 in the right spots. So we can do the for loop 5 times, 1, 2, 3, 4, 5. But if you notice, we don't have to do it 5. We don't have to do 5 comparisons every time. But first, let's code the idea that we have to do the for loop 5 times. So we encapsulate this for loop in another for loop, but we have to change the index for this for loop. So let's change it to j. So I think this accomplishes that goal to only do this 5 times. And then if you notice, we don't have to do 5 comparisons every single time. We can lower the amount of comparisons. We don't have to go from 0 all the way to 5 every time. We can actually lower it by 1 for each iteration. So instead of going all the way to the end of the array for each iteration, since j is incrementing by 1, we can actually subtract j here. So in the first time, j will be 0, so we'll do 5 comparisons. In the second iteration, when j is equal to 1, it's only comparing the pairs that we want. So now we do, if j is equal to 2, the same idea. J is equal to 2, num1 size will be 6. 6 minus 2 minus 1, 6 minus 3, there's going to be 3. So I is only going to go up to 2. So it's going to go 0, 1, 2. So it's only going to compare these two. And that's what we want for this third iteration. If we just change the for loop in here to this, then we're ensuring that we're actually following this. So let's run that. And there you go. So we passed the test case, and no surprise there because it's already sorted in the first iteration. If it was that really bad case where it was 6, 5, 3, 2, 2, 1. If it was that really bad case, then this sorting algorithm would actually be good enough for that. All right, so this sorting algorithm that we just implemented is called the bubble sorting algorithm. And it's a really nice algorithm because it's really easy to understand. It's really intuitive. And if you have any questions, I know the first time that I learned this in university, I was confused. And it takes some time to understand. You have to go through it a few times to understand it. But when you really understand it, you realize it's actually really simple. All right, so this was the merge sorted array Leetcode breakdown. And there's actually many ways that you can implement this. This is not the only way. This is just the way that I was thinking when I first looked at it. If you have an alternate solution, feel free to let me know in the comment section. I'd be curious to see what you come up with. But overall, I really like this solution because it's really simple. You just merge them and then you sort them, and that's it. Alright, so Leetcode is really good. It gives you some nice coding challenges, and these are really fun to do, and it doesn't take too long to do these coding challenges, and they can really help prepare you for some job interview questions, because in the job interview they'll probably give you some coding challenges that are similar to this one. With that said, I would like to say, and this might be controversial, this might offend some people, but I don't think you should put too much time on Leetcode challenges. Maybe when you're in the interviewing process, when you're starting to apply for jobs, maybe yes, you can start doing Leetcode, but I think your focus should be more so on personal projects. Personal projects, in my opinion, is where you're going to really learn the most when it comes to your programming journey. And when you start to apply for jobs, you're going to be picked up for interviews not because of how many Leetcode problems you've done. You're going to get picked up for an interview because of the personal projects that you did. When you go into these interviews, the employer will be asking you more about your personal projects and ask for more detail on how you implemented certain things in your projects. Leetcode challenges may come afterwards when they just want to do a sanity check to see if you can actually code. Then they'll give you some sort of coding challenge like a Leetcode coding challenge. So don't take it the wrong way. Leetcode is good, and that's why I did this coding challenge, just so you can see how I think and how I process these kinds of coding challenges. Alright, like I mentioned earlier, if you're just starting off in your programming journey and you don't know where to start, you can download my 30-day beginner coding challenge. And it's a 30-day guide where I teach you how to build those 4 beginner programming projects. It's really beginner friendly, and I go step by step on how to build each one and go through the tutorials that you need to build each one. So download that in the link in the description. Alright, that's it for this week's video. I hope it was clear and helpful for you, and if it was clear and helpful, please leave a like, share, and subscribe to the channel. And if you have any other questions, like I mentioned earlier, feel free to let me know in the comment section and I'll be sure to answer you there. And if you want me to do more videos like this, like these coding challenges, be sure to leave some feedback, because I may not do any more coding challenges if you don't give me any feedback. So if you really want me to do these kinds of challenges, please leave a comment or at least like the video. Alright, so that's it for this week's video. Thanks for watching, and I'll see you in the next one. Peace.